All right, guys, today we're doing day 3 of permutation, which is special cases. I have a lot of stuff already filled out here, so feel free and pause the video and go back if you need to. But the very first types of equations, how many different ways can you arrange stuff? We're just going to use factorials here because it's pretty simple. If you can arrange the letters in the word PIG, so you can go IGP, GIP, blah, blah, blah. How many different ways are there to do that? There are 3 letters in PIG, which is why I'm doing 3 factorial. And so 3 factorial is just 3 times 2 times 1, which is 6. Okay? But what if some of those letters are repeats? So again, there are 3 letters in the word boo, so that's why the 3 factorial goes on top, but the O is repeated twice, which is why I'm dividing by 2 factorial. 3 factorial divided by 2 factorial is just 3. Okay, and so that's kind of the formula that we're going to use. In Mrs. Denna's last name, she has 5 letters in her last name. That's always the numerator. There is a repeat. The N is used twice, so 2 factorial on the bottom. When you crunch that number, you can do it either by hand or you can type that into the calculator. You get 60. So what if the word gets a little bit longer? What if there's a lot more letters that are repeated? So there are 11 letters in Mississippi. That's the numerator, 11 factorial. But the S is repeated 4 times, so that's why I have a 4 factorial down here. There's also 4 different I's, so there's another 4 factorial down there. And then the P repeats twice, so there's a 2 factorial. So each of these letters corresponds to a number, and so this one's like for the S's, if you will. S has 4 of them. The I, there's 4 of those, and there's a P, there's 2 of those. When you type this into your calculator, make sure that you put parentheses around the entire denominator. Otherwise, it might only do 11 factorial divided by 4 and then multiply by these 2. So you'll want to use parentheses in your calculator. Go ahead and type that in and verify that you get the right answer here. It's 34,650. Really big number. Okay, so number 5 as well, same kind of thing. In the word attractive, there are 10 letters. I have an A that is repeated twice, so that's here. And I have T that is repeated 3 times, so that's there. And again, when you type that into your calculator, put parentheses over the denominator, and you get 302,400. Okay, another type of problem that's a similar way to do these types of things is how many ways can you arrange flags, or you can arrange beads or whatever if you have a bunch of red ones, a bunch of white ones. And so it works kind of the same way. Pretend like it's 13 letters and there's only 2 different letters in the word, but there's 13 letters total. So out of 13 different flags, the red is repeated 5 times and the 8 is repeated 8 times, or the white is repeated 8 times, excuse me. And when you crunch that number, again, we get 1,287. Check that with me in your calculator. Don't forget to put parentheses around the denominator. So I went through that kind of quickly, but that's the rule of thumb for arranging letters and stuff. Now I have some vocab for you to copy down: linear permutations and circular permutations. So it's exactly the way it sounds. Are you arranging people in a line where one person goes first and one person goes second, one person goes third? We've already done problems like that. Those are just regular permutations, and the formula is n factorial. It's like how many different ways can you line up 8 people? 8 times 7 times 6 all the way down. What if you were arranging people at a circular table? So there's not really a starting point. That's the big difference. One of them is with a starting point and one of them is without a starting point. Okay, so at a circular table, how do you tell like who is first? You don't. And so for that case, we use n minus 1 factorial. So it's just a little bit different. We have this thing called the reflection principle also. You'll see that used in like bracelet problems, which you'll see when I get to in just a second, but it's a circular permutation, so it's circular like this, but it has a line of reflection. And so what you have to kind of think about, we'll talk a little bit more in class about this, but if you're putting beads on a bracelet and there's no like clasp on the bracelet, so they just go round and round and round and round where there's no starting point, essentially what you can do is flip the bracelet over, and that does not represent a different permutation of those beads. So if you arrange the beads in order and you put them all on the bracelet, you make this really pretty pattern, whatever. If you flip the bracelet over, that's not a different permutation. So technically we have half as many permutations in a bracelet because you can flip it over. Why don't we do that for a table with people sitting around it? Because you can't flip a table with a bunch of people over. It doesn't make sense, okay? And so it's either a circular reflection principle situation or it is linear. This is going to be the kind that have a clasp. Okay, so I have a couple practice problems for us to do involving those. How many different ways can you arrange 9 people at a circular table? So in this case, it is a circular permutation. And so I'm just using the formula above, n minus 1 exclamation point. There is no starting point there, and it's 9 people, so 9 minus 1 exclamation point, which is 8 exclamation point, which is a pretty big number. Happens to be 4320. Might have that above somewhere. That's okay. How many ways can you arrange 9 people at a table with 1 window seat? So this is our starting point or point of reference. That means you have 1 person that goes there, so you have 9 different choices of people to go with the window seat, and then 8 choices, and then 7 choices. So it's kind of like doing that slot method. The window goes first, you have 9 choices there, and then you work your way around, 8, 7, ... So it's 9 factorial, not 9 minus 1 factorial. When there's a window seat, it acts kind of like a linear situation. So 9 factorial is 362,880. So kind of like a starting point or a reference. This gives you like a linear. It acts like a linear situation, okay? So that's why I'm kind of using these formulas from above. The first one I did was a circular permutation. It's a circular table. That's this one. I have it here, and a typical example is a circular table there. There's the formula. In this case, if you have a window seat, that's your fixed point as a starting or a reference, so you just use n factorial. So those are those 2 examples. How about a bracelet situation? This is a reflection because you can flip a bracelet over. Just keep that in mind. It doesn't say anything about a class, so this is a circular reflection. And the formula for that is n minus 1, so 6 minus 1 factorial over 2. Remember, when you flip that bracelet over, that doesn't represent a different arrangement of beads, but it might look different, but it's still the same arrangement. That's why you cut your number of permutations in half. So we have 5 factorial over 2, which is 60. Okay, and then almost same exact equation. How many ways can you arrange 6 beads on a bracelet with a clasp? This makes it like a linear reflection. So when you have a clasp, that means you have a starting point, okay? And so the formula for that is just the 6 factorial over 2, which gives you 360 ways. Okay, so hopefully that makes sense with those formulas that I was referencing up at the top. We do have 4 different formulas there, and it can get a little bit tricky to try and remember which one to use when, but those are your very basic examples that you'll see in this class. Okay, now let's do a little bit of algebra. So solving for n, these are kind of tricky, but I think they're fun. If you remember the formula from the very first day of notes, flip back to the beginning of your packet, we have a formula for NP2 for permutation out of n permutate 2 things. The formula for that, I'm just going to write it here, is n factorial over n minus 2 factorial. And if that equals 56, how can I solve for this thing? And so remember, the trick for solving these factorial type of simplification problems is to start writing the first 2 terms or first 3 terms from the top. N factorial means n times n minus 1 times n minus 2, on and on and on. So I'm going to write factorial there divided by n minus 2 factorial equals 56. And the whole reason I did that is because now I can cancel the n minus 2 factorials. When you distribute here, you get n squared minus n. And now I just need to bring everything over to one side so that it equals 0, so I can factor it and solve it. N squared minus n minus 56 is 0. That factors n minus 8, n plus 7. I get 2 answers, 8 and negative 7. But just keep in mind we can't permutate negative numbers. So our answer is 8. You can check that by checking in your calculator really fast, and you can plug in the 8 here and do 8 permutate 2, and you get 56. Okay. The last one is a little bit harder, but again, I'm going to use the formula for this p n comma 6 situation, and that is n factorial over n minus 6 factorial. That's the formula for permutations. And then 56 times, same thing here, n factorial over n minus 4 factorial. Okay? When you cross multiply, this times this and this times this, what you can do is cancel your n factorials on each side. And so that's an easy way to simplify really quickly. And what I'm going to do instead of cross multiplying, what I'm actually going to do is just bring this up here, and I'm going to turn this into a 1, because remember when you cancel something, you divide it, and it ends up being 1 on the other side. So when I do a cross multiplication thing, I end up with this. Okay, so all I did is I brought this up here like I was cross multiplying after I canceled my n factorials. And when there's nothing left over here, the way that I canceled them is by dividing. When you divide something by itself, you end up with a 1 here. Okay, so now what I want to do is try and simplify these factorials. So n minus 6 factorial, if I start writing that out, I'm going to get n minus 6, n minus 7, n minus 8, n minus 9, because it keeps decreasing. So I don't want to write out the numerator. I want to write out the denominator, because I'll go n minus 4, n minus 5, n minus 6, and then I can cancel the n minus 6's. So I'm going to keep the 1 here, keep the 56, keep the n minus 6 factorial, and start writing out the bottom. N minus 4, n minus 5, n minus 6, on and on and on. I'm going to write a factorial after that. Now those cancel. So I have 1 equals 56 over n squared minus 9n plus 20. I just FOILed this out to get here. Now I can cross multiply. Just put this over 1. So I get n squared minus 9n plus 20 on one side, 56 on the other. That's just after cross multiplying. Bring the 56 over so that you get a 0 on the other side. That gives you negative 36 here. When you factor that, you get n minus 12, n plus 3. You get 2 answers. Remember, you can't permutate negative numbers, so 12 is our answer. Okay, so make sure that you review those formulas so that you can do a little bit of algebra with those. Those can be a little bit tricky. Put maybe a star here. You will have to do some of those on the quiz and the test, but it's just starting with the formula and then using what you know about simplifying factorials. Thanks for watching, you guys. Bring questions to class tomorrow, and I will see you later.